Hey, Algebra 1 friends, we're in section 12.2, and today we're going to talk about rational expressions. Our vocabulary is basically rational expressions and excluded values. Let's talk about that quickly. In the word rational expressions, I want you to see the word ratio. Okay, and we know ratios can be written as a fraction, and we can talk about rational numbers, and rational numbers are any numbers that can be written as a fraction or a ratio between integers, right, remember that. So a rational expression could be like any number that you have, any expression that you can write as a ratio. So it can also contain like a polynomial or a quadratic like this over some other quadratic, x squared plus 3x minus 5. I'm just making stuff up at this point. X over x plus x squared. All of these are considered rational expressions. The key word here is ratio. Excluded values. Now, you remember how we did extraneous roots? In a way, excluded values are kind of the same idea, except they come exclusively here from the denominators. So what would make your denominator 0? That's going to be an excluded value. So let's say I had a problem that had like 1 over x minus 7, or I had an expression that was 1 over x minus 7, and for some reason I was setting it equal to something, or I was trying to solve something. There's one value that x just can't be no matter what. X could not be 7, and that would be an excluded value. I'll exclude that value from solving my rational equation if I had one, because I have this part of the expression suggest to me that if x were equal to 7, this whole thing would be shenanigans. It would be nonsense. It would not mean anything. Got me? Cool. Let's move on. So here in example 1, we're asked to state the excluded value. What did I tell you in the introduction? The only thing we're thinking about when we talk about excluded value is dividing by 0. So I'm not even worried about my numerator. I'm just worried about my denominator. So basically, if you couldn't do this, if you couldn't eyeball it, you set the denominator equal to 0 and you solve for that variable. The excluded value here would be, add 6 to both sides, drum roll please, m is equal to 6, or not in our case. The excluded value would be 6. Here in example 2, it's a little bit harder to see the excluded value like we were able to do in example 1. It requires us to think a little bit more deeply. It requires us to factor. So basically, I'm taking this denominator and I'm doing exactly what I said. We're going to set it equal to 0. But when we have a quadratic and we are solving a quadratic set equal to 0, we know we've got a couple ways of solving it, or actually 3 ways. We can factor, we can complete the square, or we can use the quadratic formula. I am going to factor this if I can, because it's easier than, pulling out the whole, complete the square, and quadratic formula. You know what I'm talking about, babies. All right, x and x. What two numbers multiply to give me a positive 6, yet those two numbers also add to give me a negative 5? I'm hoping you're saying negative 2, negative 3, and if you were, you are correct. I factored this correctly, and now I'm going to solve each one by setting each factor equal to 0. If x minus 2 equals 0, or if x minus 3 equals 0, we get that x is equal to 2 or x is equal to 3. But remember, we're trying to find out what x cannot equal. So x cannot equal 2 or 3. Those are my excluded values, 2 and 3. Oftentimes in word problems, we get introduced to new concepts. Don't be afraid when that happens. Know that you're not expected to have known this. It's just your way. They're giving you new information so you can solve the problem. Let's do that with example 3. We're going to use a rational expression. Here we have Kenyi, and he's helping his parents landscape their yard, and he needs to move some large rocks. He plans to use a 6-foot bar as a lever. He positions it as shown to the right. So we did this in the last section. Here's a fulcrum, here's the bar. He's going to be, pinch bar, I don't know why it's called pinch bar, but he's going to be pulling this down to plop that up to get it out of the way. Makes sense? Sure does. Couple things we need to know. The distance from the fulcrum to the end where he's going to be pulling is called the effort arm. The distance from the fulcrum to the rock is going to be called the resistance arm. So here's the information we're given for part A. The mechanical advantage of a lever is given as LE over LR. What is that? Well, LE is the length of the effort arm, and LR is the length of the resistance arm. We're going to calculate the mechanical advantage of the lever that Kenyi is using. So I took a moment to have fun with highlighters so I can highlight exactly what I need. We're going to calculate this average, and so basically it's going to be orange over green. The orange value is 5 feet, so LE over LR is going to be 5 feet over, what would this be? They said the whole thing was a 6-foot bar. This has to be 1. So his calculated mechanical advantage would be 5. I don't know what the units are on that, but our calculation's on point. So here's part B of that problem. It says that the force placed on the rock is the product of the mechanical advantage and the force placed by the end of the lever. If Kenny can apply a 180-pound force, what is the greatest weight he can lift with his lever? Okay, so this is kind of cool. So what I got from that statement was that the mechanical advantage times the applied force is equal to the weight of the rock, all right? That part is implied, so it's going to be the force that's going to be placed on the weight of this rock, and so I'm going to set them equal to one another. So let's see what's the heaviest rock that Kenny can deal with. So he's going to put we know that the mechanical advantage was 5, and he has an applied force of 180 pounds. And so we're going to calculate that. When we multiply 5 times 180, we get 900. Am I making that up? What? Kenny is incredibly strong to be able to move a 900-pound rock. So sometimes we're called to simplify expressions when we have rational expressions, and you guys have done this before. I don't know, I've got an extraneous little thing here. So you guys have done this before. It's a matter of simplifying variable over variable, and so the first thing I might do is deal with the numbers. So -7 over 21 is going to end up being, the whole thing's going to be a -1 over 3. So I dealt with that first. Now I'm going to deal with my A values. I've got 2 at the top, 5 at the bottom. That's going to leave canceling them out 3 at the bottom, right? Remember, 2 minus 5 is a -3. A to the -3rd means 1 over A to the 3rd. Or you could look at it as having 2 A's up at the top, 5 A's at the bottom. Cancel, cancel, 3 A's are left at the bottom. So we had a few rules going way back when on dealing with problems like this. And then finally, we're left with B squared at the top, right? Because there's 3 B's, 1 B, cancel the B's out, we got 3 squared. So we end up with B squared over 3A to the 3rd, and that's negative. The 1 is understood up there. The problems get to be a little bit different when you realize that we could have polynomials in the numerator and denominator. And so where it was really easy to consider the factoring, because basically it's 7 times A times A times B times B times B times over 21 times. You know what I mean? It's basically factored out for you. You can see that here we're going to have to factor this out. Right? We're going to have to factor it out. We got to do a little bit of work. So let's go ahead. We're going to factor the numerator, see if we can, and factor the denominator, see if we can, and that might help us out. So when I factor the numerator, I'm thinking about 2 numbers that multiply to give me a -15, yet add up to give me a -2, and those numbers would be -5 and 3. And in the denominator, I'm thinking of 2 numbers that multiply to give me a -12, yet add up to give me a -1. And that would be -4 and a +3. And so looking pretty good. This is very similar to having a problem. Watch the analogy. CA over D times A. Cancel out the A's and we're left with C over D, right? That makes sense. This is a thought bubble, by the way. You're just thinking about it. You're like, wait a minute, this is something I could do. So now x minus 5 is a number. X plus 3 is a number. X minus 4 is a number. X plus 3 is a number. These are the same numbers being multiplied. Literally, I can cancel them out. Why am I making weird sound effects? I don't know, but there's something else I do need to tell you. And that other thing is that before I just cancel it out and just get rid of it and say, hey, you're gone, peace out, I need to remember something. There are some values that, what did we call them earlier? We didn't call them extraneous roots. We called them, I forget what they were called. I really do. We will call them excluded values. So we need to talk to this problem and say, hey, there's some values that are excluded. And one of them is x is equal to -3, cannot happen, right? And x is equal to 4, also cannot happen. So these would be the excluded value to this problem. So when you simplify, you definitely want to make sure if you cancel something out to write the excluded value that was contained in the cancellation. I know that was a lot of gobbledygook. I hope it made sense. Let me know if this is sounding crazy. We should talk one-on-one if you're feeling uncomfortable. We're going to do the same thing here with example 6. We're going to factor the numerator. Can factor out a 3. We're supposed to simplify then state the excluded values. We're tough. We got this. So x minus 5, because I factor a 3 out, I factor the greatest common factor, and I'm left with 3 times x minus 5. And now the denominator, let's see what I can factor. Looks like I can rock an x here, an x here, two numbers that multiply to give me 10. Positive 10 yet add up to give me a negative 7 would be negative 5 and negative 2. And so what I'm going to do is tell you my excluded values. They are x cannot equal 5, nor can x equal 2. The most important one here, though, is this one. That's not what I meant. The most important one here is this one, because when I simplify this, boom, boom, those two terms go away, and my simplified answer is 3 over x minus 2. So even though positive 2 is an excluded value, you can see that that value would be excluded. Here, when I simplify x divided by, when I get rid of the x minus 5, you lose the fact that this was a value that's excluded. So you need to make sure and show up with that. All right, so that's an important point, and we're going to end this section on that important point. I hope you guys feel comfortable with the material. Let me know. We'll talk if you want some extra help or extra discussion. Take it easy, guys. Bye-bye.